Hey, today we will be looking at inverses of relations, lesson 5. And basically, we are looking at the examples in your chapter 3 transformations of functions example booklets. And we're looking at the first example, 1 on page 21. So just remember, functions that are reflection of each other in the line y equals x are called inverses of each other. A reflection in the line of y equal x results in x and y values switching places. The inverse of function f of x is denoted by the function f of minus 1x. So this is your y equal x. So this is called the reference line. So if we have a reflection of this, it should be parallel to this reference line. So first thing we want to do, we're going to do a mapping. So this is my y equal f of x graph, and I already putting my reference points on the original y equal f of x. So we have our f of x function. So we have f of x. Write that down. We're going to map that to f of minus 1 of x. So what are we doing? But we have x here. We more or less switching them into y and x. That will be our new coordinate for x and y. We're switching the x and y, so this becomes your new x and your new y. So the first point we can use is 5, 3. So 5, 3, we switch that around, becomes 3, 5. First coordinate point. The next point we have is 3, 1. We switch that, we get 1, 3. And the third point, f is negative 2, 6. And switching both of the coordinate points, we have 6, negative 2. Now, these are the points we will be using to graph our inverse. So I start off with 3, 5. So 3 point and 5 is up here. So I go along 3, then 5. Then my other point is 1, 3. So x is 1, y is 3. Point there. And the final point, reference point we have is 6, negative 2. 6, negative 2 there. So now here we're going to connect these points, and I'll use broken lines. Now notice it right. It's right along the previous one. So let's connect it. So this is my f of minus 1 of x. Right. Now, to ask you to indicate the domain and range for each. So if you look at our original graph, our domain will be from x is negative 2 to 5. So the domain, and always use square bracket in this case because it means a point actually begins at this point, negative 2. So negative 2, and it ends at the point 5. So that's my domain for my original graph, f of x. My range will be the lowest point here, which is 1, going up to the highest point, which is 6. So that's y of f of x. Now let's find for the inverse, the domain. The reason I use a square bracket is because the points actually the graph begins at a certain point. This dot tells me it begins here. There's no arrowhead to indicate it goes on to infinity. So at this point, my x value is 1, so 1, and it ends at the point at 6. So this graph goes down here and then all the way here at the point 6. So the range will be from the lowest point here, which is -2, to the highest point 5. So it's -2 to 5. So just remember, whenever you're doing the inverse, you're more or less switching the coordinates, using the coordinates of the original graph to switch them. Okay, let's look at example 2 on the next page. Now, in this example, you're asked to determine the equation of the inverse of each function and sketch a graph of f of x and the function. So first, let's sketch the graph of f of x, and then we'll find the inverse of this function. So notice this is a straight line because it has a for y equals mx plus b. So your slope is half, the y-intercept is 1. So I can find my y-intercept, which is 1 here, and I know my slope is half, meaning my rise is 1 and my run is 2. So I go up from my y-intercept 1 and I run 2. So my next point here. And just for make sure that you're on the right track, you can try the other way around. You can go down 1 and to the left 2. So now this is my original graph, y equals half of x plus 1. Now, to find the inverse of it, we'll follow the same process we did earlier in one of the examples, where we interchange x and y. First, we make the f of x y. So we try y is equal to half x plus 1. And then we interchange. In other words, we switch. So this becomes x is equal to half y plus 1. Now we solve for y. So solving for y, we isolate the y by, first thing, we move the 1 to the left, becomes negative. Now, to solve for the y, we need to find the reciprocal of a half. So we multiply half by 2, both sides. So now I'll just do it one more step here. X minus 1. Let's put a bracket around that. Multiply this by, I'm just going to make it look a little bit neater here, 1y. So we multiply this by 2 here. So this will, 2 into 2 is 1. So we are left with y is equal to, and to make it look nicer, I'll put it over here, my y, and I'll leave my answer like this. Now I can expand on this to look at the y equal to mx plus b format, and this becomes 2. It makes it easier here because I can now use my y-intercept and the slope to graph the inverse, because they ask us to sketch a graph. So I'm going to use this as my y-intercept, -2, which is here. Now, my slope is 2, therefore I go up 2 and run 1. So this is my next point here. I go up 2 and run 1. Notice this point here will become my invariant point. That's where the two lines intersect, or the points do not, the points of the transform graph is the same as the original. So I am going to use a ruler to connect those points to make it look really neat. So I'll do that right now. So this is my graph here. So put my arrowhead here. Oops. So this is, I can write it like that now. 1 equals 2x minus 2. And this is f of x half x plus 1. Okay, let's go on to the next example, B. In this case, we have quadratics. A little bit of change from the previous question we just completed, which was a straight line. So we follow the same pattern, except in this case, we're looking at a quadratic. We need to find the vertex. I'm just going to remove this arrowhead. It's a little bit too extensive, so because I'll need some space here to work. So first of all, let's sketch this graph, and then we'll find the inverse algebraically. So one thing you have to remember from your grade 11, that we have this in the P and Q format. This is going to be your vertex. So it becomes your vertex is 2, 5. And since A is positive here, the graph is going up. So we find a vertex which is 2, 5, which is way up here, in this case here. My point 2, 5. And this graph is going up. They didn't give us any restrictions, so we can put the arrowhead on this graph. It's kind of a crooked here, but I'll make it look nicer. Okay, I say it's a sketch I'm doing. You don't have to be precise, but you have a good indication of it must be going up. Next step, we would like to now find the inverse of this graph equation and then graph it. So first thing we do, as we did in the previous example, we interchange x and y. So we have this as now becomes x is equal to y minus 2 squared plus 5. Then we solve for y. Now to solve for y now, we're going to take the 5 on the left side. So I'll give myself some space here, but we're saying x is equal to y minus 2 squared. So be x minus 5. Now, I like my y on the left side, but it doesn't make any difference, but I'll leave it as it is right now. And now I need to solve for y by square rooting both sides of this graph, and that would eliminate the square to the power 2 here. So squaring both sides, what I'll have is x minus 5 is equal to y minus 2. Then I take 2 on the left side, becomes positive. Now remember, this is plus or minus. I'll leave that there for now. So plus or minus root of x minus 5 plus 2 equals y. By the way, you can easily put the y on the left of it. It's the same equation. So we'll do that. Y x minus 5 plus 2. Now,
Max, can you contact the office?
Now, if this is a function, we have to have this as positive, or you can have a negative depending on the restriction on the domain. So the function in this case, if you want to make it the function, now this becomes the root of x minus 5 plus 2. This now is my vertex, the graph. And the graph is positive. We can do so. My vertex is 5, 2, which is right here. Then my graph will be going upwards if I were to look at this. So this is, now it's a function. Now, if I didn't remove the negative, then it will not be a function, it becomes a relation. So if I were to continue this like that, oops, this part would be if I were to have y equals plus or minus. So I'm restricting the range. In this case, I'm restricting the domain for on where x is less than 2 to give me this graph here, f of, so make it a function. Okay, but if you were to not, if you didn't restrict it, then the sketching graph would be the complete parabola going towards the right. Okay, and I'll just write here vertex is 5, 2. Okay, and now we'll do 2 more examples. Go under the booklet. Actually, we'll just do one more. I'm just going to show you how to prove. And here in the case, they ask you to determine algebraically if y equal f of x minus 3 and y equal x plus 3 over 7 are the inverses of each other. Essentially, you're finding out if once you find the inverse of this, it's the same as what's given here. So let's go ahead and determine the inverse of y equals 7x minus 3. So I'll write it down, y equals 7x minus 3. Okay, and now I switch them. So interchange, as you use the word, interchange. X and y. So we have x is equal to 7y minus 3. And the next step, I solve for y. So we have x minus 3 is equal to 7y. X minus 3 is equal to 7y over 7. Divide both sides by 7. So 7 going to 7 one time. So y now I can change it, x minus 3 over 7, which is the same as given here. So we can say they are inverses of each other. The final one, because of time, I'll show you the exact, here's the work done. So here we have determined algebraically whether the function of y equal x negative x squared plus 3 greater than or equal to 0 and y equal square root of 3 minus x are inverses of each other. So it's the same process as before, except now we are looking at a restriction. So here we have y equal to x squared minus 3, and I switch the x into y. By switching the x and the y, I solve for y. So y is equal to plus or minus x plus 3. Now, which is the same as given here, except they have the x negative at towards the right. And switch it over, and yes, the answer is an inverse of minus square root of 3 minus x is the inverse of y equal to negative x squared plus 3, where x is greater than 0. And you have to indicate x has to be greater than 0, but in this case, x here has to be greater than 3. So x in this case has to be greater than 3 for this to be valid. If x is, if x is not, because if you put here x is 3, then it becomes 0. And if it's less than 3, it becomes negative, and you cannot, no, sorry, this has to be, x has to be less than or equal to 3. Okay, so I've posted the answers to these questions on the blog. So previous days, so you can look at, if you haven't done these yet, you can check your answers at the blog. Thank you, and see you again on, or you'll see me again. I'll talk with you again on Monday. Have a good weekend.